All right, nerds and nerdettes, let's get going. All right, so this is on the back of S'mores Part 2. So it looks like this. We did the first 3 problems last time. Okay? And we're going to look at this equation. We have when elemental aluminum reacts with iodine, aluminum iodine is produced. Okay? So we're going to step by step and write out our equation. Okay? So we have elemental aluminum, which is just aluminum. And we know the symbol for that is Al. We're going to add it with iodine. Now this is one of our diatomics, so something's by itself plus I2. And now we're going to make aluminum iodide because this is a compound. Okay, we have 2 crisscross. We know our charge of aluminum is +3, iodine is -1. Crisscross, 1 aluminum, 3 iodides. We're going to produce Al, our cation, our positive one, and iodine. +3, -1. Okay. Now we got to go back and balance. These are our reactants, on our right's our product. Okay. Aluminum's fine. Iodine, there's only 2. Over here we have 3. So let's multiply this by 2. 2 times 3 is 6. 3 times 2 is 6. 2 aluminums, 2 aluminums. Okay? So our mole ratio for this equation is 2 to 3 to 2. Okay? That's what we're starting with. And we're going to highlight these 3 different colors. Okay? So our elemental aluminum, yellow, okay, so any light color. Our iodine, let's make blue. And let's do green. Aluminum iodide. Actually, let's make that guy pink. Green. Green. Okay, those are our ratios. That's what's going to help us solve our second step. Okay, so let's take a look at number 3. If you start with 4.02 moles of aluminum, how many moles do you want? Okay, so we're going from moles to moles. Okay, if you don't have one of these already, I'll make sure I pass these out. So the last time we were working on this, we were going from grams to moles was our first step. Moles to moles, which is our second step, and then moles back to grams. 1, 2, 3. Okay. Now in this problem, we're just going from moles to moles. So that's a 1-step problem. We're going to start out with 4.02, and you have to have this on here. Every unit has to have a number. Sorry, every number has to have a unit. Moles of aluminum. Okay. So, and we want to know how many moles of iodine will be produced. I'm sorry, of aluminum iodide. Okay, so if we go back to our equation, we're going from here to here. Okay, those are the numbers we have to have. On the top here we have moles of aluminum. So down here we need moles of aluminum. So we're going to have 2 moles of aluminum. For every 2 of these, we make 2 of those, a 1-to-1 ratio. 2 moles of aluminum iodide. Anytime we use our coefficients, we want to color code those. That way we know where they came from. All right. So right here, this is pretty simple. 4.02 times 2 divided by 2. It's going to give us the same number. If we have this many moles of aluminum, and it's our limiting reactant, meaning that's what we're going to run out of first. We have plenty of iodine. Okay. We're going to have 4.02 moles, cross out, of aluminum iodide. There's our answer. It has our unit, circle. Okay, let's do number 4. Now we're starting out with 1.05 grams. Okay, so now we know the weight of it. Anytime we're given grams, we have to change it to moles first. And same thing, still of aluminum. How many grams of aluminum iodide will we produce? Okay, so now this is another three-step problem. We're going from grams, okay? We have to divide it by our molar mass. That'll give us the moles. We do our mole ratio step 2, and we want to know grams back to grams. Three-step problem. So we have 1.05 grams of aluminum. Okay? And aluminum. Let's take a look. We have 26.98. grams of aluminum. Okay? Always dividing it by our, and this is what 1 mole of aluminum weighs. Okay? Top number is always 1, your bottom number is always your molar mass. Okay, that's our first step. We do that, grams and grams cancels out. Next step, we gotta look at our ratios. We wanna make aluminum iodide, same as last problem, okay? So we're going from here over to here, okay? Same thing, 2 moles of aluminum. Mole of aluminum, this is from our equation, 2 moles of aluminum, will make us 2 moles of aluminum iodide. Okay, same thing, we're going to color code those. And if we stop here, that'll tell us, cancel, cancel, how many moles of aluminum iodide we have. But we want to take it one step further. We want grams. Okay, so what we then have to do is take iodide, 126.90. We have 3 of those. 126.9 times 3 plus our 1 aluminum plus 26.98. Okay, looks like our molar mass is 470.68. Okay, so this is, remember these coefficients are moles. Okay, so 1 mole of aluminum iodide, okay, that's how we know that goes in the bottom there. That weighs 407.68 grams. Okay, so now grams canceled out, our moles of aluminum canceled out, our moles of aluminum iodide has now canceled out, and we're left with grams of aluminum iodide. Okay, and that's what we're looking for. Okay, so this is our 1, 2, 3-step problem. Okay, so let's type this all in here. 1.05 divided by 26.98 times 2 divided by 2, that'll give us the same thing. And then multiply by 407.68. All right, and we should have, if we start off with 1.05 grams of aluminum, we should end up with 15.86 grams. Okay, now for molar mass is 2 digits. Okay, and when we get our answer here, we're round to 1, so we'll just say 15.9. We should have 15.9 grams. Okay, and I'm going to type that in one more time, divided by 26.98 times 2 divided by 2 times 407.68. There we go. All right, let's do number 5. If you start with 1.02 grams of aluminum, how many grams of iodine would you need to get it to react? 1.25 grams of aluminum, how many grams of iodide? Okay, so we're going to have a different ratio because we're not using aluminum iodide, we're now using iodide. Okay, so we have 1.02 grams and aluminum. Same step. Okay, that gets rid of grams. We've changed it to moles. How many grams of iodide? Okay, so now we go back to our equation. We're going from aluminum. We want to know how much of this do we need. Okay, so we have a ratio of 2 moles of aluminum to every 3 moles of iodine. Okay, so we're using different numbers in our step 2 because we're asking about something else in our chemical equation. We're no longer asking about what we're going to produce. We're asking about our other reactant. Okay, that cancels out. That cancels out. We do want to know the weight of it, not just how many moles. So we have one more step. Okay, so we need to know what 1 mole of iodine would weigh. It's I2 because it's a diatomic. Okay, so 126.90 times that by 2. So this would be 253.80 grams. Okay, so now we have this number times 1 divided by 26.98 times 3 divided by 2 multiplied by 253.8 divided by 1. Moles cancels out, and we're left with grams. All right, and I get 14.39. We're going to round it to 1 decimal point, so we should have 14.4 grams. All right, last one. You have 52.3 grams of aluminum. Ooh. We also have 54.6 grams of iodine. It's going to be 2 separate problems. Let's move this up a little bit. Okay, how many grams of aluminum will be produced? What's your limiting reagent? What's the excess reagent? Okay, we're going to get rid of this how many grams are we going to produce. We'll do that a little bit later. Okay, right now let's just figure out which one's our limiting reagent. Okay, so we got to figure out which one are we going to run out of first. Okay, we can't compare the weights of them because that doesn't really mean anything. We have to compare the moles. Okay, so we have 2 separate problems. We're going to do that and that. We know that we're going to divide this by 26.98 grams. That would be our 1 mole of aluminum. And down here, this is iodine. Okay, so our 1 mole of I2, okay, would be that guy, which we already did, 253.80. Okay, so both of these we're dividing by our molar mass. Okay, so let's take a look here. 52.3 grams divided by 26.98, that gets us 1.9. We have 1.9 moles of aluminum. Okay, that's what we're starting with. All right, now down here we have 54.6 divided by 253.80. That gets us 0.2 moles of iodine. Okay, so now let's take a look here. So pretty much in this, if we had a 1-to-1 ratio, we would definitely be running out of this first. We have a lot less moles of iodine. Okay, but we don't. We have a ratio of 2/3. Okay, so if we look back at our equation, for every 2 of these, we need 3 of these. Okay, so we need more iodine to begin with anyway. Okay, so we know that this is our limiting reagent. We need more of it, and we actually even have less. This is what we're going to run out of first. Okay, so now I want you guys to take this number, okay, and we want to figure out how much moles of aluminum iodide we're going to make. Okay, our new ratio is 3 to 2. Okay, so we're going to take that answer, set up your box. If this is I2, sorry, if this is moles of iodine 2, that means 3 should be here, and 2 should be up here. 3, 2. Okay, and then I want you guys to figure out the rest of the problem, figure out how many grams of aluminum iodide will be produced. Okay, but this would be this 3. Remember, we're making moles of aluminum iodide. Okay, so that's our ratio. Go ahead, figure out that last part of that problem.